Okay, so here's our third part in the lecture on solid, toxic, and hazardous waste. Again, remember the goal is shrinking the waste stream, shrinking it, making it as small as possible. We recognize we will always make trash, we will always make waste, but can we shrink it as much as possible by reusing things, reducing our use, and then if we do reduce, can we recycle? Can we use certain products, packaging, etc., that will shrink the waste stream? Can we process the wastes appropriately? And again, the goal here is just reducing what we're doing, shrinking that stream. The challenge is some of the waste we produce can't be shrunk really. There's some ways, but some of it we're always going to produce some amount of hazardous waste. So hazardous waste is defined as any substance that can be fatal in low doses, toxic, carcinogenic, mutagenic, or teratogenic. So hopefully those terms look familiar. We've covered all those. We've talked about toxic, carcinogenic substances, mutagenic, teratogenic, etc. Is this waste ignitable at less than 60 degrees? Does it combust fairly easily? So that's a huge issue. Is it corrosive? And is it explosive or highly reactive? Now, please keep in mind, you don't have to be all of these to be considered hazardous. You could just simply be one, or a different one, or a different one to fall under hazardous waste definition. So obviously the ones that are the worst are the ones that meet all 5 of those criteria or qualifications. That's not good. So where's it coming from? The vast majority of hazardous waste production, chemical and petroleum industries. All right, so if we're tackling the hazardous waste production side of this issue, this is the target. Can we look at ways to decrease our consumption of chemical and petroleum products that would decrease the production of hazardous waste? Can we reduce the amount of use? Can we streamline it, et cetera, et cetera? So again, the idea is focus on the area that produces the greatest amount before we tackle other areas to try to get, as I say, the biggest bang for our buck here. So when they're produced, the waste gets disposed. And unfortunately, throughout history, it hasn't been disposed of correctly. Some of that's lack of knowledge, some of it's lack of interest, finances, etc. But when areas are identified as containing toxic waste, they go under the Superfund heading. Okay, this area is dangerous. Post signs, keep people out, no trespassing, deal with it. Now, initially, the remediation or the dealing with the toxic waste would have been up to who owns the property. Well, what if it's a business that's been abandoned? You're not going to go after former business to make them come back and pay for something they did 50 years ago. So these things sat and sat and sat in a state of disrepair, and nobody was dealing with it because of trying to understand who's responsible for it. So the Superfund Act provided finances, provided federal funding to support cleanup. And what it does is legislation provides immediate response to a hazardous spill. So if there's a toxic spill, get in, clean it up. And then money for the cleanup and remediation. Then let's worry about who should be held accountable for this instead of letting it sit out there, potentially exposing the public to unsafe conditions. So the challenge is the funding for cleanup of Superfund sites has consistently gone down. We see a trend. Under Republican administrations, it goes down. During Democratic administrations, it goes up. We go back to Republican administrations and the funding goes down. So it's kind of this pattern of support for cleanup of Superfund sites and hazardous waste disposal. So a big challenge is across the US, EPA has identified 1,344 sites that they classify on the National Priority List. These are nasty sites. They are Superfund sites that have toxic chemicals, toxic pollutants that need cleanup now. Notice the map. Most of these sites sit over the top of aquifers. That's a huge issue because you have these sites that contain toxic waste that are sitting right over the top of the aquifer that you're probably drinking out of. So it becomes a huge, huge problem. You look at Illinois, look at the Superfund sites or the National Priority Listing sites in Illinois, basically all around the Great Lakes here. That's from the old steel mills, the smelting plants, industry around the Great Lakes, same thing on East Coast, West Coast, but all these through the Midwest here. A lot of these in the Midwest are major contaminated sites that sit on top of aquifers. So it's a huge, huge issue when we deal with water quality that we have these sites that need cleanup on top of our aquifers. In towns or cities and villages, usually larger urban areas, we have things called brownfield sites. Now, these are contaminated properties that are within larger cities that have been abandoned. This was an old steel mill plant. It's been abandoned since the 50s or 60s, or here's an old shipyard, or here's an old bus repair station, etc., old gas station, that they're abandoned. So the problem is nobody wants to take these sites over. Nobody wants to buy it. It's contaminated. How do we get rid of it? So with the brownfield sites, the challenge is the soil and the water are usually contaminated. So there is some funding, the amount goes up and down, that supports redevelopment. Can we go in and remediate and clean this up and make this safe for people? Now the challenge is what level is required to be considered safe. That's where you get into a lot of problems or challenges with trying to rehabilitate brownfield sites. But it's definitely something that if urban environments invested more into, it would help with the urban sprawl issue. So instead of building outward around your city edges, go in, clean up your brownfield sites, remediate those, repair and clean those, and you may have the land you need for continued urban growth and development. So, all right. So here's the big picture of hazardous waste management options. Obviously, let's start with producing less. Yes, produce less waste because there's less demand for the products that create the waste. Can we reduce our consumption? When we do produce it, can we recycle any of those waste products or reuse them? One waste product for one industry may actually be a fuel source for a different industry. So finding ways to do things like that. Or are there ways to use less toxic alternatives? Ingredients that are not toxic, that still get the same job done. Now the frustration is a lot of times the less toxic alternatives may not be as effective, but are we willing to make that trade-off? I'll take a little less efficiency in the cleaning product if it means I'm not poisoning myself. So those are things we have to see. Does public support this? Do people want something that's environmentally more friendly, which may mean they have to do a little more work, or they, no, I just want the simple route. It's okay if it's toxic and considered a pollutant. So there's a lot of challenges involved with this stuff. The other option, the next step is, can we take that hazardous substance and convert it to a less hazardous product? So there's different ways of doing this. Start with physical treatment. Simply, so on the physical treatment, can we take that toxin, capture it, filter it, clean it, isolate it, do something with it so that way it doesn't continue to be hazardous, physically treat it. Next option is incineration. Can we incinerate it? Can we burn it, reduce the volume to ash? So in some cases, you're looking at 80-90% reduction in volume. That's huge. So now you have this smaller volume of hazardous substances to deal with. Chemical processing. There's our third possible option. Can we transform these things to non-toxic substances by mixing them with these other chemicals? Does that create and basically bind up something and make it non-toxic? And then bioremediation. This is definitely one that would be great to see more of. Can we use plants, microorganisms, bacteria, fungi, etc., to take up pollutants and toxins out of the environment? Lots of different plants do this. And can we get more of this happening? So that way these plants, here's all our toxins, they absorb the toxins, then some of them, in some cases, they break down the toxins, neutralize the toxins, detoxify it. Great. Other challenges, though, with bioremediation, if you're talking about a plant and it absorbs all these toxins, if we then use that plant for food or for a biofuel or something else, does it then just release the toxins? So that needs to be cleared more, clarified more, and studied a lot more to make sure we understand really what we're doing with bioremediation. But in a lot of cases, we can use, like I said, soil microorganisms like bacteria and fungi to actually break down toxic materials. Huge potential there. And ultimately, what we may do, or we are doing, and probably need to make sure we're doing it very efficiently, is storing this stuff. So with storage, some of this hazardous material is going to be stored permanently. We have no place to put it. Or do we shoot it off into space or dump it on another planet? That seems a little unrealistic at this point. But storing it permanently. And there's two ways that we're doing this. One's called retrievable storage. It's a secure facility that stores it safely. And the idea is at a later point in time, let's say 50, 80, 100 years from now, we go, wow, we could use this toxic waste for, we'd be able to get in and get it back, retrieve it. So a lot of times these are stored in old salt mines or old facilities that have been abandoned, that are secure facilities that won't leach this stuff into the aquifer or the water table, things like that. The other one is what's called a secure landfill, where we have multiple, and I'm stressing that, layers of liners here to protect this. So they start with bedrock, solid bedrock down here. And then we have clay, a lot of clay. Clay is soft, permeable, malleable. It forms, it won't break, it won't crack. If there's an earthquake or geological movements, that clay usually adjusts and it doesn't have problems. And then we dump in all our toxic stuff, all of our nasty stuff stored here. And there are different, and then a cap. Let's cap it with clay, cap it with topsoil, etc. And we're monitoring it. So we monitor these things to keep an eye on it. You're monitoring the gas production, the methane removal, so there's a source of energy. But we're also monitoring the well water by testing that over here and just trying to make sure that this stuff is stored permanently in a facility that's not going to suffer from erosion, environmental damage, age, breaking down, things like that. So basically we're creating a time capsule that's never supposed to be opened. The problem is they're never going away. So how many of these do we want to stick in our backyards and throughout the US and throughout the world? So bigger picture, can we reduce the production of this stuff before we worry about great ways to store it? So ultimately, let's see if we can do more what they call tracking cradle to grave of wastes. Where does it start? How is it moved? How is it treated? How is it transported? Where does it eventually wind up? Does it sit there forever? Let's keep an eye on all this stuff and make each step of this process, each area, industry involved in this process accountable. So if you're transporting and you have a leak, you're responsible. If you're treating and you have a problem, you're responsible. If you're securing it in a landfill and the landfill leaches, you're responsible. The goal is trying to keep us all safe because this stuff's out there and a lot of this is never going away. So we need to keep an eye on it, but ultimately reduce the waste stream.